Welcome everybody to this webinar being presented by Providence Engineering Environmental, aka Providence ORIS. And today we're going to be talking about the new features in our latest release of our Beest software, Beest 12.11. So by way of an overview, this version of Beest includes support for the AirMod version 2.3.132 alpha keywords. And remember, alpha are sort of research grade options that will not be used if you're doing modeling for a permit, let's say. We'll also be talking about some changes we made to output contours that you will see when you're looking at the output from AirMod. A change in how you set up and run AirMod. We call it the Select All button. And then talk about the incorporation of the AirMet version 2.3.132 keywords. Specifically, we'll talk about the incorporation of on-site or prognostic and sort of what the definition now of on-site is, and talk about the core overwater processing algorithm that's been pulled into AirMet. So, whoops, I hate that. Let's talk about the AirMod 2.3.132 alpha keywords that have been incorporated in this version. And those are keywords related to modeling emissions from aircraft. And that's ARCFT OPT and ARCFT SRC. We also have new keywords having to do with the highly buoyant plume algorithm, HBP and HBP SRC ID. We've also included ways to set up the debug file keywords for aircraft and highly buoyant plumes, which is HBP, DBG, and aircraft. And then a final alpha keyword is area source meander, which is AREAMNDR. So in the aircraft keywords, AirMod is set now that you can model aircraft sources either as an area or a volume source. And when you use these aircraft keywords, you can now account for plume rise from them as well. And to invoke the plume rise, you're going to actually have to have an hourly varying emissions input file. And that file for each of those sources, either area or volume, is going to include these keywords: mfuel, which is the fuel burn rate in grams per second; the thrust, which is the aircraft thrust in newtons; the VAA, or aircraft speed, in meters per second; AFR is the air-fuel ratio; BYPR is the bypass ratio, which is greater than 0 for a turbofan, or like a jet engine, and it's minus 999. It's a shaft-based engine, like a piston engine. And then there's RPWR, which is the rated power in kilowatts. And for that one, it's a minus 99999 data flag for turbofans, but greater than 0 for shaft-based aircraft engines. And then finally, we have SRC angle, which is the landing takeoff angle with the ground, and that is in degrees. So again, if you're going to be invoking this and you want to be able to account for plume rise from these aircraft takeoffs and landings, you'll have to have an hourly varying emissions file to go with each of the sources. And we're not going to go through that here, but I just wanted to point that out, that that's something that has to be included. So if you're going to invoke aircraft sources, again, these are alpha options. So if you go to Control Options in Beest and go to the AER Default tab, check the alpha box there, and this will then allow you to use these aircraft keywords. So here's aircraft opt and aircraft SR. So if we go to source options up there at the top, and kind of towards the bottom of the page, we have a button called aircraft group. When we click it, we have a pop-up and then we have a checkbox that says, now you have the option to include aircraft sources, and it reminds you you're going to have an emissions file with those aircraft parameters that we just discussed a couple of slides back. And this is, again, like a group. So you can either say that all of your area poly, area circle, line, or volume sources are aircraft in this particular run, or you can tell AirMod which sources are aircraft. And so you would click select sources, and then as they're listed, you highlight them, select them, and it turns them red so that they're part of the aircraft source group. So changing from aircraft sources to the highly buoyant plume algorithm, this highly buoyant plume formulation applies to those point sources whose plumes penetrate the top of the convective mix layer. So it's a warm afternoon, and you have stacks that are really pushing out effluent with a lot of velocity, a lot of buoyancy, and they may be penetrating into the stable layer above. So as an alpha option in the air mod, you can use it for point sources, which is a traditional vertically exiting stack, but can also be applied to point cap and point HOR point sources as well. The highly buoyant plume keyword, or HBP, appears in control options, and you'll set it up as an alpha option, and you define those highly buoyant plume sources in source options. So here we are again in control options, and if we go to check the alpha box there, we then go over to source options. And at the bottom is another button, HBP group. So this is where you're going to tell AirMod which sources you want to treat as these highly buoyant plumes. And just like before, you have the option to actually to invoke this first, as this is like kind of like a switch to tell you that you're going to be using these highly buoyant plume sources. And oops, you can say, I want all of these three kinds of point sources as highly buoyant plumes, or you can just select the ones that you want to, which is the second button here. So here's an example where I said that, yes, I want to invoke highly buoyant plumes, and I'm going to go have my list of sources, and I'm going to check stack and stack 2 as being highly buoyant plume sources. So the algorithm will be applied to those two, but not to stack 3. Again, you double click or select, and it turns them red. And then when you're done, you just click OK. So like you did with source groups. So we mentioned those two new algorithms. We've also included support for generating debug files for highly buoyant plumes and for aircraft sources. So once again, you go to control options, make sure you selected under AER default the alpha button there in the center, and at the bottom is the button for debug files. And here's a list of all the things that you can have debug files generated for. And right there, kind of close to the middle, is HBP debug files, and below it is aircraft debug files. So basically, in either of these cases, you click File and you tell Beast what you want to name that debug file. Caution though, um, these can produce very large files. Um, so yes, you can do it, but hopefully you'll have enough disk space to hold these large files. The next alpha keyword is area meander, and it can be applied to area sources, rectangular area sources, area polygon sources, area circle sources, and line sources. Remember, the line source algorithm is basically the same as rectangular area, just has a larger aspect ratio. This area meander keyword and the existing fast area or fast all can be specified in the same model run, but in that case, meander will not be applied to those source types that are listed. And to invoke area meander, it's very easy to set up within Beast. So here we are again in our control options. And if we go to AER default and make sure we've selected alpha and go to AER non-default, that next tab over, and there in the bottom right corner is a button called Alpha Options. And if we click it, we'll have a menu here of different alpha options that come with their mod. And we know at the top of this is not for general use, not for regulatory use in any event. But down at the very bottom there's a checkbox that says use area meander, and it will apply plume meander to rectangular area, area polygon, area circle, and line sources. And then we have a citation there of where to go in the user's guide to see more information on how to set this up and explain what it's doing. Okay, so that's our alpha keywords. Let's switch gears and talk about changes to output contours. So as we are all aware, EPA recently dropped the annual PM 2.5 standard from 12 micrograms per cubic meter to 9 micrograms per cubic meter. And they've also come out with a new recommended sill of 0.13 micrograms per cubic meter. So with those two changes, we have updated the automatic contour routine for annual PM 2.5 in Beast. So if you go to display output graphically, and over here in the options button, kind of in the middle of the screen, left-hand side, kind of towards the middle, go to options, and there's contours, this is the third tab over, and there's where you see a circle contour and receptor level sets. And there's several different kinds, ranging from dynamic, which kind of looks at the data and sets up something for you automatically, and certain combinations of pollutants and averaging times based upon sills and standards. So for PM 2.5 annual, this is what's been changed. And so you'll see that we now range from the new sill of 0.13 micrograms per cubic meter, all the way up to 9 micrograms, which is the actual NAQS. And in this example right here, the way it was set up, we have the first contour at the sill 0.13. The second contour is twice the sill. The third contour is 3 times, 4 times, 5 times. And then starting with line number 6, it's just 5, 6, 7, 8, and then 9, where it tops out. Again, if you want to change this, you're certainly able to edit either the value or the line thickness and color, however you want to customize it. But this is what the default auto um, output contours are. So we now have a new select all button that shows when you're getting ready to run AirMod. So if you click the run AirMod button shown here, and at the top now we have a button called select all. So as you know, or as you may have seen previously, basically when you get ready to do a run, you check the pollutant of interest, which is the boxes there in the middle under pollutant. And then you would go over to the Met files on the right-hand side and select what Met years or Met files rather go with that pollutant and an averaging period. So we actually had a customer who said it would really make life a lot easier if I could just, when I got to this point, just select all and have Beast do all this for me. So if you come here and click select all, it will automatically check all pollutants and Met file names. So you click it, and all of a sudden, all the pollutants are checked and all the Met files are checked. Now, in this example, let's say you're looking at SO2 1 hour, and you see that box is checked. And under Met files, it's selected the 5 individual years as well as the 5-year concatenated metadata set. So for SO2 1 hour, here you can just go through and deselect 2017, 18, 19, 20, and 21, and leaving you with just that one file. If you were looking and then go to SO2 annual, you would still see those 6 Met files checked, but in that case, you could just deselect the concatenated file, and it would just use those 5 single years and so forth. So rather than uh, doing uh, number of pollutants times number of Met files, click, 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 you can say select all and then just go in and take out the ones that you won't need. And so it makes life a little easier, makes the work a little quicker as well. If you do this and you think to yourself, no, wait, I didn't want to do this, the select all button here at the top has changed to deselect all. And if you click deselect all, it'll zero out or uncheck all of those check boxes that are there now. And it turns out that since this is in Beast, you can do this as well as for the running ISCST3 and ISC3 prime. So we'll switch gears again and talk about the AirMet version 23132 keywords. So in addition to being able to process National Weather Service data, NWS, our AirMet GUI can also handle on-site data. And I'll mention the kind of the different definitions of that. It can also handle meteorological data generated from a prognostic meteorological model, like the Weather Research and Forecasting or WRF model. You would take the WRF data and process it through the Mesoscale Model Interface Program or MMIF. Um, or you can also process over water data, either measured or coming out of a prognostic model. And for those overwater applications, we now can invoke the core algorithm. So here is AirMet's setup screen, and notice that we've selected Weather Service surface and Weather Service upper air data, and we've selected on-site or prognostic data. So on-site or prognostic, again, either measured on-site, over land, over water, or output from a prognostic Met model. Now, the on-site data can be either over land, you think of having a meteorological tower, at an on-site station, or over water, such as observational data from buoys. So a buoy is not what you would strictly think of as being on site, but this is sort of the nomenclature that EPA is using for describing non-National Weather Service meteorological data. And if you're interested in getting the buoy data, there's a link shown right there, www.nationaldatabuoycenter.noaa.gov. So we're going to go over here to the OS1 or On-Site 1 tab first. And you have two options here. Is it real on-site, either on land or on water, um, data, or is it prognostic data coming out of WRF and MMIF? And then down below the location, you have a checkbox where you tell it, is this site on land or over water? And if it is over water, when you check the water box, up above, the core button activates, and we click it, and we'll get some more options that we need to tell AirMet for doing the overwater processing. So here's the core options pop-up. We have 4 tabs here. And the first one is related to the core algorithm itself. And basically, when you're here, you just say, I want to check enable core processing. And even if you read this in the user's manual, which is listed there at the bottom of the slide, current EPA guidance is not to enable either warm layer processing or cool skin processing. I believe that they say that it has not been tested thoroughly enough yet. So when you get to this core tab, just check enable core processing, and then that would be it. So let's look at the next 3 tabs. You know, surface roughness, and the default is to calculate surface roughness based on surface friction velocity, or U star. EPA guidance, and the default check here is to calculate surface roughness based on that U star value. The next tab, mixing heights. Again, we have a default, which is the method used by AirMet. There are some other options shown there. Again, EPA is not recommending you try those because they have not been thoroughly tested or vetted yet. Excuse me. And finally, there's this other tab, and basically leave those 5 boxes blank in order to use the default values of sea surface temperature, measurement depth, mixing height for gust calculations, minimum mixing height, minimum ammonia to Obuchov length, and potential temperature gradient. So if you don't put anything in there, AirMet will use the default values that are shown there in parentheses. And oh, and one more new feature to mention about the AirMet 23132. If we look at the OS2 or On-Site 2 tab, down there at the bottom, we have a new selection called Vector Averaging for Wind Speed. However, wind speed, when you're doing meteorological processing, should be a scalar value, not a vector average value. So use this with caution, and if you're wanting to use it for whatever reason, make sure that your permitting authority is okay with this. And that brings us to the end of the Beast 12.11 presentation. I didn't introduce myself at the beginning. I should do that now. My name is James Redd. There is my email address and phone number if you have any questions about this, or any of the software in general. Please feel free to reach out.